Magnetic materials and their role in modern technology. Magnetic materials play a crucial role in numerous technologies and industries all around us. From mobile phones to MRI machines, they are essential components that make these devices work. These materials are used in a wide range of applications, from data storage to electric motors to medical equipment, and have revolutionized the way we live and work. In this article, we will explore the different types of magnetic materials, how they are used, and some of the fascinating technologies they are responsible for powering. What are magnetic materials? Magnetic materials refer to materials that possess magnetic properties. There are three types of magnetic materials, namely ferromagnetic, diamagnetic, and paramagnetic materials. Ferromagnetic materials are the most common types and include iron, nickel, cobalt, and their alloys. Diamagnetic materials show slight tendencies to repel magnetic fields, while paramagnetic materials have a weak tendency to attract magnetic fields. How do they work? Magnetic materials have the ability to create and respond to magnetic fields. Magnetic fields are invisible forces that can attract or repel other magnetic materials. When a magnetic field interacts with a magnetic material, it either attracts or repels, depending on the type of force being exerted. This interaction is due to the alignment of the material's electrons. Ferromagnetic materials, for example, consist of small atomic magnets known as spins. These spins are arranged in such a way that they are all pointing in the same direction, making the material highly magnetic. When a magnetic field is applied, the spins in the material realign themselves to create a new magnetic field. Once the magnetic field is removed, the spins return to their initial position. Ions. Magnetic materials and technology. Magnetic materials' unique properties have led to their widespread use in modern technology, including 1. Data storage. Magnetic materials are used in hard drives, which are used to store data in computers. Each hard drive consists of a spinning disk coated in a thin layer of magnetic material. This magnetic layer has tracks etched onto it, and small magnets are used to represent data. Each magnet is polarized, representing either a 1 or 0. The data on the hard drive is read by a read/write head, which reads the magnetization of the magnetic layer, giving information on the stored data. 2. Electric motors. The rotation of an electric motor is due to the interaction between a magnetic field and an electric current. The current creates a magnetic field, which then interacts with the field of the permanent magnet. This interaction produces a torque that causes the motor to rotate. Magnetic materials are typically used as the magnets in these motors, due to their high magnetic stir NGTH instability. 3. Medical imaging. Magnetic materials are used in medical imaging equipment such as MRI, magnetic resonance imaging, machines. MRI machines use strong magnetic fields to perform imaging scans, which help doctors diagnose and treat various ailments. The formation of images in MRI machines involves the interaction between a magnetic field and hydrogen atoms in the body. The atoms are magnetized by the machine's field, and when these atoms return to their initial positions, they emit a signal that is converted into an image. 4. Speakers. Speakers use magnetic fields to convert electric signals into sound waves. When an electric signal is supplied to a speaker, it interacts with a permanent magnet, causing the voice coil to move. The movement of the coil produces sound waves that we can hear. 5. Sensors. Magnetic materials are used in a range of sensors, including in vehicle speed sensors and compasses. The speed sensors in modern cars use magnetic sensors to monitor wheel rotation and send this information to the engine control unit. Magnetic compasses, on the other hand, rely on the Earth's magnetic field for direction. 6. Renewable energy. Magnetic materials are used in wind turbines and other renewable energy systems. These materials are used in the construction of the generator and the magnets used to produce electricity. Wind turbines use magnetic materials, such as neodymium and dysprosium, to create powerful magnetic fields that produce electrical energy. 7. Magnetic levitation. Magnetic materials are used to create magnetic levitation, allowing objects to float in the air without touching anything. This technology is used in maglev trains, which use strong magnetic fields to levitate and propel trains at high speeds. The trains do not have wheels, and they float on a cushion of air, because of the magnetic fields, providing a smoother and quiet ride. 8. Magnetic separation. Magnetic materials are used to separate magnetic materials from non-magnetic materials. This technology is frequently used in mining industries to separate valuable minerals from unwanted materials. For example, iron impurities can be separated from sand using magnetic separation. 9. Defense technology. Magnetic materials play an important role in defense technology. For example, magnetometers, which measure magnetic fields, are used in missile guidance systems and submarine detection. Magnetic materials are also used in stealth technology to reduce the radar cross-section of aircraft, making them difficult to detect by radar. 10. Magnetic hyperthermia. Magnetic materials can be used to treat cancer through a technique called magnetic hyperthermia. This technique uses magnetic nanoparticles that are injected into cancerous tissue. The particles are then heated using an alternating magnetic field, which causes the cancerous cells to be destroyed without harming the surrounding healthy tissue.